Good morning, everybody. Today is September 1st, and we are meeting for Computer Science 1010 only. And so this meeting is not mandatory for ES 1060. ES 1060 is welcome to join, but this is expressly for our computer science students. So first of all, I have 3 people online. Can you give me a thumbs up if you can hear me? Because that's always the first order of business, isn't it? Ah, thank you, Michaela. Gotcha. All right, the rest of you are off the hook. We got her done. Okay, good. Thank you, Garrett. I'm glad to hear that. I just always want to make sure that we're cooking with gas. So, all right. So the first thing that I want to talk about is what our schedule looks like, because I realized that I have your assignments laid out for quite some time. So I wanted to just give you a little calendar view of what was going on. The first thing was on August 28th, which I believe all of you have already done for me, is we had a discussion board, and then we had a short assignment number 1, which was how are you going to access Excel and MATLAB. And the one thing that I wanted to bring up, everybody who submitted it did a great job, but you should not buy anything. Okay, so it's free. So don't if they want you to buy stuff, yeah, just say no. So we're good to go. All right, the next point that we are going to have is by September 6th, which is, believe it or not, next Wednesday. So 9/06, we have this temperature conversion, the handwritten problems, which are to be handed in via Zoom, or excuse me, via Moodle. So you'll, just like you did with the short assignment, which part of the first assignment was just making sure that you had access to Moodle and that you could submit things to me in a way that I could read it. We'll do that again for September 6th. Now, coming down here, you'll be completing by Monday, September 11th. You'll be completing the MATLAB onboarding and sending me your certificate showing that you have 100% completion on that program. And I've talked to several students and come to find out the last part of that is quite difficult. So that's good to know, because I had completed the onboarding for a prior version of MATLAB, so I haven't completed this one yet. So you guys are ahead of me on that. So then following that, on Wednesday, September 13th, we are going to have another homework, which is the pseudocode for the same problem as the temperature conversions. And then last but not least, is what we're going to talk about today, for Computer Science 1010 only. In other words, this is not for the ES 1060 students, but the Computer Science 1010 will also submit a flow chart. Okay. And we're going to talk a little bit about flow charting today, but I'll show you before, let's see, I think maybe, just a second. Gotta find my Zoom meeting again. There we go. All right. So here is our schedule of the assignments that are due. So we're still, it looks like a lot, but we're 2 weeks out. So that's just tabulating the material for our from our Moodle page in a little bit different manner. All right. So everything that I've written on this piece of paper is also here on our Moodle page, but that's kind of a different way to summarize that material. All right. So before we get started with the material on how to flowchart, does anybody have any questions about the material so far? Does anybody? Okay, great. That we wanted to discuss. Very good. All right. So I'm going to go ahead and share the screen. Everything that I'm talking about today is organized under week 2 computer science only. So in other words, if you take a look at our Moodle page, there's the week 2 for everybody, and then there's the week 2 for computer science only. There are several videos that we're going to talk about completing a flowchart, creating a flowchart in Excel. This is an optional way to do it. I'm going to give you some different ways to do a flowchart, but if you want to make it in Excel, this just tells you how to step through it. And it's kind of handy because, especially if you just don't like to do handwritten documents, you can do it in Excel and not worry about that. All right. So the first thing is, what is the point of a flowchart? Okay. This particular link is a graphical and verbal, just a website. The other links that I sent you are videos, so it'll help you with that. But basically, a flowchart is a graphical representation of steps. So a flowchart has the characteristics of, we take that algorithm that we are writing for our computer program, and we put them into a defined process using symbols in order to describe how we're going to program the algorithm. And so it's a visual description of what we are going to do once we start working with our programming language, in this case with MATLAB. But it's a graphical and verbal representation. The other thing about it is it builds directly from the pseudocode that we're going to be writing. And it comes before we start actually using any computer language at all. So once again, a flowchart is language independent. In other words, regardless of the language that you use, at least with a high-level language, your flowchart is going to look exactly the same, or we could say it's language agnostic. Okay, so there are a couple of different things I just want to throw in here. And let me just put this back up so we can take a look before we get going with this. The first thing is that my philosophy of teaching is that everything should all work together. So that's why I'm building it this way. I'm trying to teach you all of the steps and to introduce you to all of the steps of programming. And if I achieve my goal as a teacher, we will never do any busy work and we'll never do any side quests. It's all about reaching a goal. And our goal in here is to learn how to write structured code. And to, the fact that we use MATLAB it's more than a detail, but what I really want you to learn is to learn a structured language. And so that's why we're using MATLAB, and then of course later Excel. But basically everything that we do is working toward the same goal. The other piece of the puzzle is this lends us toward having larger projects that I try to break into steps, which are what the submissions are all about. But if you'll notice, as you start working through them, the submissions are 50 to 70% the same. We're doing the same kind of a problem over and over again, and that's to build that skill. The other reason is because as far as you get here until you actually, everything that we've done here, that we're going to be doing in terms of the temperature conversion problems would be exactly the same if we were programming in Python, or if we were programming in some other weird language like Fortran, or if we're programming in MATLAB. So everything that you do for the flowchart, up to the flowchart, is going to be exactly the same. So the next secret I'm going to tell you is, after we get done with MATLAB entirely, after we write a couple of programs in MATLAB, we're going to do the exact same problems again in Excel. So that means that 70% of your work will be done. So all these things, everything should work together in an ideal world. And that's what I'm aiming at. All right, so let's go back to the idea specifically of what a flowchart looks like. So let me share my screen. All right, so basically this is a particular kind of a flowchart, but every one of these shapes has a different meaning. At the beginning and at the end of a program, you always have an oval, and sometimes they're an oval and sometimes it looks more like a cylinder with two half circles on it. but basically the meaning is the same. And that just indicates that you're going to start a program. Then if you look down here, you'll see the name of each one of these symbols. But the oval, or as you can see even here, they've done it this way with a cylinder with 2 half circles. So it's just, this is a little bit harder symbol to find if you're using a computer program. The oval just is more available, but they mean exactly the same thing. And they mean a terminator. You're either starting or ending the program. A box would be a particular operation. So like if we go back up here, that's where you're doing a calculation. So for us, for example, in your box, you might have your formulas. F is equal to this in terms of C, C is equal to this in terms of K, whatever you're doing in that particular step. A document means that you have a printout. So at the end, we're not really going to print stuff out. We're going to print things onto our screen. So the fact that this is supposed to be a piece of paper that's torn at the bottom is sort of a throwback to legacy programs where everything came out on a piece of paper. It's kind of interesting too, just historically, just to take a pause with that. I've been thinking about computer science over the years, and I was introduced to the idea of punch cards, but it was a legacy at the time when I was in school. But really, back in the day, first of all, in the 1950s and before, all computer programming was done with like physical input switches. And then they went to punch cards, and then they went to terminals where you would write code, and then you would compile it and see if it worked, and then you'd have to go back and recode. And now we're at a stage where you really don't have to print anything off, where you can do it on an interactive environment, and a programming environment like MATLAB will actually help you decode. If you write something incorrectly, it'll say, what exactly did you mean here? So every single time it's become a huge advantage. But getting back to that, this just means that you have a printout, or this is where you would print out when F equals 30 degrees, C equals this, K equals this, and R equals this, or this is invalid input. So something is going to come out and tell your user what that looks like. All right, a diamond like this represents a decision, okay? So in our case, that would be a decision in the programming would be if the user has input F, then we do a calculation for C, K, and R. If the user has input degrees in Celsius, then we would output F, K, and R. So it's your decision. And that's basically what is called an if-then statement or an if-else-if statement. Okay, so you'll have all of those symbols will be useful to you in this particular program. All right, now the next one, which is data, represents information entering or leaving the system. So for example, this would be where your program will say to the user, which variable are you going to use, or what is the scale that you're inputting your temperature? And then they would decide, so that would be a data. They would either input an F, a C, a K, an R, or if they input something else, it would just be invalid. But that's an input. And then you would next probably ask them, they would say, I'm putting it in an F, I'm putting it in degrees Fahrenheit. And you say, what is the value of the temperature in degrees Fahrenheit? So you'd have some data input there. Okay, an on-page reference. I don't necessarily think we're going to be using this symbol, but basically it just continues if the matching symbol contains the same letter elsewhere. You could use it, but it's not, you can get around using this particular type of a operation. I don't want to call it operation, but anyway, on-page and off-page references, I do not suspect we will have to do that. You could use a delay or bottleneck, but once again, I do not think we're going to be doing that because that just means there's something here that may or may not be able to continue, that we need to look at something in terms of validity. And I believe that we'll set up our program rather in terms of a condition, which is if the temperature falls below absolute zero, it's not okay. If the temperature, if the input is not an F, C, K, or R, it's not okay. But so I think we'll do it in terms of a condition instead, which is part of a decision structure. All right, and then last but not least, we have arrows which indicate the direction of flow. So we start at the beginning and we end at the end, and everything else goes through in a stepwise fashion, whether the stepwise is just top to bottom or if there's a loop. Okay, so if we take a look here at their flow chart, which of course is different than ours, but there's some similarities. We're going to start here, do something where we input data, do some operations maybe, but really what we're going to do is jump right into a decision loop. Okay, so for example, you're going to get this data and you'll say something like if input equals F, then something's going to happen. If not, then does the input equal C? And then you'll have something else that'll happen. And if not, does the input equal R? And if it doesn't, does the input equal C, or excuse me, K? And then finally, last but not least, if it doesn't equal any of those things, then it's invalid. Okay, so this is just sort of like a basic way of setting up your algorithm. All right, so I've drawn two little things here, not very much, right? But the other thing I want to tell you is you can draw these by hand. So when you submit them, you know, the symbols are this is back from olden times when people were drawing things by hand a lot. So if you draw everything by hand, as long as it's relatively tidy, that will be fine. The other thing you can do, like I said, is take a look at that video and see how to set it up in Excel if you're comfortable with Excel. The other thing I wanted to let you know is at my office, I should have brought them today. I'll put a picture of them up on my Moodle page for you guys, but I have flowchart templates, which are just little pieces of plastic with cutouts so that you can just trace the symbols. And that can be useful as well. The other thing is, you may sometimes just using a plain sheet of white paper like this can be a little vague. So outside of my office, I have a different kind of paper, which those of you that have had classes for me before have probably used over and over again, but you are welcome to come by my office and get some of this paper. So let me show you what it looks like. It's green, but the green is not really the exciting part about it. The grid is the exciting part. So this is called engineering composition paper or engineering comp paper, or sometimes it's just referred to as the green paper. So the top here, and it doesn't have to be green, but it's quadrille paper is the real name of it. So the front of the paper just has a very light grid. It's actually from what's printed on the back, and you can just sort of see through it, but it's really helpful in drawing straight lines. So please feel free to come by my office, get some of the paper. Feel free to use the templates if you want, and if not, hand draw it on whatever you want and send it in that way, but make sure that that you're comfortable with the whole process. All right. So any questions at this point? All right, well, all right, students, that is it for today. Short class. I wanted to remind you that next Monday is Labor Day, so we will not have class on Monday, September 4th. We will, and we won't have lab that day either. You won't have any classes. We will, in this class, have class on Wednesday, September 6th. And then on Friday, September 8th, I will be off campus, so we will not have class that day as well. So next week is a very short week for this class. All right, but as always, I am available by appointment. I'm available in my office. You can call me or text me or send me an email. And if you run into any problems as our workflow starts coming in, just let me know and I'll get you squared away. All right. So I'm going to stop recording. Have a wonderful weekend, and we will see you Wednesday of next week.